All right, so we have a problem here. It's another typical type of ellipse problem. This is a good example for how to find all the critical parts of the ellipse. So you may want to follow my lead here. Of course, this is being recorded after I have taught some basics. So what we did here was we looked at, or what we've done so far is we looked at ellipses and what makes ellipses and all the components. And if you're going to do this problem with me on your own, then you need to have your book open at page 716 and page 717, because that's where a lot of this information is going to come from. So we have an ellipse equation up here, and we know we have an ellipse because it says it, and we need to find the center, vertices, foci, and eccentricity. So we need to find all 4 points, or all four parts. What I told you in previous times was that we can go out and we can write this in its purest form. Go to page 717 and write it as x minus h squared over a squared plus y minus k squared over b squared, or vice versa. But we don't really need to. We just need to spot a few things. First thing, it is always good to go ahead and identify A, B, and C. Identify A, B, and C. Now, A is always going to be the square root of the bigger of these two numbers here. 64 is bigger than 28, so I know that A is the square root of 64, which is going to be 8. So I know that my A coefficient is 8. It's the square root of 64, which is going to be 8. That means my B coefficient is the square root of 28. Now we can go in and try to rationalize this or simplify that radical, but that's not going to be necessary. It is always a good idea to leave it in radical form and not turn it into a decimal, but we're not going to really have to simplify these because we're going to end up squaring these and life is going to be good for us. Okay, now C. C is the one where we have to remember the equation. In the ellipse, you have an equation, c squared is equal to a squared minus b squared. C squared is a squared minus b squared. It's not Pythagorean theorem, but it's based on triangle trigonometry or triangle work. And so if we want to find C, C is always going to be the square root of a squared minus b squared. And we already know that a squared, well, a is 8, so a squared is 64. And b squared is, well, b is the square root of 28. Square root of 28 squared is 28. So remember, a squared and b squared will usually be those exact numbers that are under the radical, under the elliptical equation. All right, so if I take 64 and I subtract 28 from it, I can pull my calculator up on the screen here. Actually, I think I will, if I can find it. I don't have it up. I'll do it on my other calculator. If I take 64 and subtract 28, right, 64 minus 28, I get 36. So C is equal to the square root of 36, or 6. Now, if you're working through this and you want to copy stuff down, I would stop the recording right now and copy this down, because I'm about to erase all this C squared stuff here. Okay, so now we've identified A, B, and C. The next thing we should do is plot some points. Or, well, it's not a bad idea to identify H and K. So we can either identify it by writing it or just simply plotting it. But we know H is going to be 0. Why? Because this up here is really x minus 0 squared. That's how we know that. It's really x minus 0 squared up at the top. So H is 0, and K is going to be 2. So I know my center point is the point 0, 2. I know my center is the point 0, 2. So my center is going to be plotted right there. Now from that alone, I don't know if my major axis is horizontal or vertical. That much I don't know. But I can look back at my equation, and we know that if the A is located under the X, and it is, then our axis of symmetry, the major axis, has to be horizontal. So I know that my foci and my major vertices will lie along that axis right there. I know they will. If the A was under the Y, then I would have a vertical major axis. But be that as it is, we have a horizontal one, which means our major vertices then, and I always do MAJ, our major vertices will have to be to the right and to the left. So what I'm going to do is I'm just going to draw some points and I'll drag them in. I know I got to be to the right and the left. Well, the question is how far to the right and the left? Well, that's where my A comes in. A is 8, so I need to be 8 units to the right. 1, 2, 3, 4, 5, 6, 7, 8. There's one of my major vertices. The other has to be to the left. 1, 2, 3, 4, 5, 6, 7, 8. And we talked about this in class. The way we're going to write these points, one way we could write these points is this is the point -8, 2, and this is the point over here, 8, 2. And honestly, it's probably easiest to write them that way in this particular case. But if we want to stay consistent with a pattern that we're going to start to see here, then really what we can say is that our major vertices are at plus or minus 8, comma, 2. Plus or minus 8, comma, 2. So you're going to start to see your points condensed like that. So that's the major vertices, the minor vertices. Okay, now the minor vertices must be above and below the vertex at the center. Since our major axis is horizontal, our minor axis must be vertical, and so they have to be above and below. How far above and below? The square root of 28. All right, so I know that they're above and below. By looking at my graph, I don't know exactly where. I just put them there for right now. I know they're the square root of 28. If you take the square root of 28, that's got to be somewhere around 5. So I'm just going to eyeball these. 1, 2, 3, 4, 5. 1, 2, 3, 4. So they're going to be approximately right there if I want to graph them. However, I need to know what these are exactly. So let's talk about how to plot these points right here or write out the coordinates. First thing, to get to this one here that I'm circling in green, what I need to do is start at the origin. Remember, I need to start at the origin, and how do I drop down to here? Well, most people say, well, you drop down about 3. That's not correct. Officially, what we do to get down here to this blue point that I just circled is we start at the origin, and we're going to go up as far as 2, and then we're going to go back down as far as square root of 28. So really what we've done to get to this point right here, we have gone 2, we started at, I'm sorry, I should say it this way. We did not move anywhere horizontally, but vertically what we did was we went up 2, and then we went down the square root of 28. Now to get to this blue point that I'm circling here, actually I'll circle it in another color. I'm circling in red. To get there, what I need to do, again, my x part of things is 0. I start at the origin, and what I do is, pull this out of the way here so we don't mess things up. Remember, I'm going to start at the origin. I don't move right or left to get up to this blue point right here. But what I do is I go up 2, and I go up another square root of 28. I go up 2 and up another square root of 28 is what I do. So, okay, so here's what I'm really doing then. What I'm really doing is I am to get to my minimum vertices, or my minor vertices, I should say it that way. My point is going to be 0, comma, 2 plus or minus the square root of 28. 2 plus or minus the square root of 28. That is how I go to my minor vertices. 2 plus or minus the square root of 28. Now that's the x component, the y component. Let me erase some of this just to get the clutter out. Here. Well, that's just perfect. You get the general idea. Okay, the last thing, or the next to last thing I want to do is I want to find my foci. My foci find those much the same way, I'll use red for these. The foci have to lie along the horizontal major axis and have to be between. So I'm just going to put one here and one here. I don't know exactly where they are yet. I'll figure that out. I know that my foci have to be 6 units to the right and to the left. 6 to the right and to the left. So if I go over 6, that's 1, 2, 3, 4, 5, 6. That one's there, and that one's going to be 1, 2, 3, 4, 5, 6, right there. Now those are pretty easy points to plot. That's going to be the point 6, 2 and negative 6, 2. So I'm going to go negative 6, 2 and then 6, 2. So really what I have is the point plus or minus 6, 2. Those are going to be my foci, or my focal points. Okay. And then the last thing we need to do is find the eccentricity. And when we find the eccentricity, that's simply the C coefficient over the A coefficient. And if I take C is 6, 8 is 8, and that reduces down to 3/4, or if you want to turn it into a decimal, that's fine too. The eccentricity is nothing more than just a measure of how round your ellipse is going to be. The closer to 1, the more oval and long it's going to be. The closer to 0, the more round it's going to be.